Now, for gas volume stoichiometry, we're gonna need to use the, the standard volume of a gas. A gas that is at a standard temperature and pressure has a standard volume of 22.4 liters. That is going to be, okay, that is going to be one additional conversion factor that you can use, okay? Just remember this, at STP, standard volume, I abbreviate the standard volume as SD in my path, is going to be equal to, in 1 mole of that gas, you have 22.4 liters. You can use that. Okay. Mm, okay, sorry, I didn't write the reaction. Let me just write it down. So this is the reaction. So this kind of reaction is like this, okay? You have a metal that is combined with acids. When metals are combined with acids, gas bubbles are formed, okay? Those gas bubbles are hydrogen bubbles. So this is the gas that we are talking about. Okay. Now, as you can see, the equation is not balanced, so I have to balance it. Okay. So here I have three sulfates. So I'm gonna put 3 right here. Okay. Here is telling me that I have 2 aluminum, so I'm gonna put 2 aluminums right there. And just to balance the number of hydrogens, I need 3 over there. Okay, that is the first step that I do. If the equation is not balanced, I begin to balance it. Now, the next step is put the information in the place it corresponds. For example, here they are giving me 2 liters of hydrogen gas. Okay, that is going to be my product because it says that is going to be produced 2 liters of hydrogen gas. So that is going to be my givens, 2 liters. And it says how many grams of sulfuric acid. So I need to look for the mass of sulfuric acid. So which of these compounds is sulfuric acid? 1, 2, 3, or 4? Which one is the acid?
Two.
The number 2, because it begins with hydrogen. Remember, all acids begin with hydrogen. So from here, this is going to be my unknown, and this is in grams. Because I have grams, I I need to relate the molar masses. Okay. Here, the key of this problem is the grams that they are asking me. So the first step for this problem will be to calculate the molar masses. So as a first step, I'm gonna get the molar mass of sulfuric acid, and the other step will be to get the molar mass of hydrogen gas. Okay, from the sulfuric acid, I have two hydrogens, okay? Invisible one, sulfur, four oxygens. I'm going to use the molar masses, the atomic masses rounded. So this is going to be 1 times 2, 1 times 32, and 4 times 16. I got this from the periodic table. Okay, I rounded. So this is going to be 2 grams. This is going to be 32 grams, and this is going to be 64 grams. So if you add all of them, it's going to give you 100.
98 grams.
Hmm? Check, check.
98.
98.
98.
Yes. 98 grams. I cannot add anymore. Okay. Now for hydrogen, I have 2 times 1, which gives me 2 grams over mole. Now from this, I'm going to include I'm going to include the smaller masses in the reaction. So for sulfuric acid, I have 98 grams over mole, and for hydrogen, I have 2 grams over mole. Okay, those are the molar masses. Now let's take a look. After this, and I have to relate the given and the unknown. I have to relate the given and the unknown. My given, as you can see, is volume in liters, and my unknown is grams. Okay, so I have to work with my path. So with my path, I have my volume given, and take a look. If the volume is given, with the standard volume, I can get the number of moles that you can see right here. Okay, these moles, as you can see, are related over there. So volume is related with number of moles. So anytime you have volume or you want volume, you need to use the standard volume. So my volume given is going to help me to get my number of moles given. To do that, I have to use the standard volume of a gas of my given, okay? From this, I can continue. I have moles given and I need to know my number of moles unknown. So for that, moles given related to moles unknown, we use the molar ratio. And then from moles unknown to grams unknown, we use the molar mass. of my unknown. That's the path I built to actually work with my problem. So I begin to work with this problem with my given. Okay? We always begin with a given. So I have 2 liters of hydrogen gas. That is my given. Okay? And in the path it says that I continue with the standard volume. So my standard volume has moles and liters. I need to write my liters down and my moles are gonna be up. Okay? So in 1 mole of my substance, that in this case is hydrogen, I have 22.4 liters of hydrogen gas, which allows me to cancel liters with liters. So I continue. From moles given to moles unknown. I have to look at my reaction. Okay? Now, this is my given and this is my unknown. So from there, I'm gonna get my molar ratios. In the molar ratios I need to write my moles of hydrogen below, okay? Because I need to eliminate the units. So up, I'm gonna write my number of moles of sulfuric acid. So right now what I do is I just write the coefficients where they belong. I have 3 moles of hydrogen gas that are produced from 3 moles of sulfuric acid. And then I need to relate the molar mass of my unknown. So I have to write it as, okay, sorry, here I have to cancel moles and moles. So right now I have to relate the molar mass of the unknown, so I need to cancel my moles of sulfuric acid. So I put moles of sulfuric acid below. So in 1 mole of sulfuric acid, I have a mass of 98 grams of sulfuric acid. This allows me to eliminate moles of sulfuric acid with moles of sulfuric acid. How much does this give you?
8.75.
8.75. So in other words, this means that if I want to obtain 2 liters of hydrogen gas in this chemical reaction, I would need to use almost 9 grams of sulfuric acid in this reaction. Now take a look. This is the same stoichiometry that I explained you in the first portion, but I'm just including the standard volume. Now a student from the other section asked me about the first exercise from the homework, okay? And probably it was complex because the reaction is not written in the problem, but you can get it. I mean, from the word problem, you can get it. Let's see, a ver, sí, aquí está. So in the problem, this is what you have. Minor, your camera is off. Should be on. So in the problems, this is what you have. Assuming all volume measurements are made at some temperature and pressure, what volume of hydrogen gas is needed to react completely with oxygen gas. So the problem is actually giving you the reaction, but in words, is telling you hydrogen gas and oxygen gas. And what are you going to produce? You're going to produce water vapor, okay? To produce water vapor. So what I do is I translate the word equation to this chemical equation. And of course, I do not forget to balance. And from this, I relate the givens and the unknown. And here, then you get the path. It's given. It's giving me hydrogen, liters of hydrogen. Okay, and they're asking me a volume in liters of oxygen. So I relate the two. This is my path from volume given. Okay, I need to get the moles given. I need to get the moles unknown because I'm relating the two substances. And then from this, I get the volume of the unknown. And here, you know, the standard volume of a gas, that is 22.4 liters. You apply all the procedure, and this is what you get. Give me a second. Okay, give me a second because someone left the meeting. I have to write it down. Okay, sorry. Shayla, your camera must be on. Melvin, yours too. Okay, so this is like the review of gas volume stoichiometry. I cannot give you like more examples because you know there are many possibilities, but just try to remember what we saw in the first partial. That's it. And now, what happens with the ideal gas law? For the ideal gas law, we need to use the ideal constant. Okay. We need to use the ideal constant. The ideal constant is known as R. Okay? And this R is going to depend on the givens that you have in the problem. For example, here, they're giving you moles, they're giving you liters, and they're giving you Celsius. So this is going to help you to get the best value for R. Now in this problem, it says, what pressure will be exerted by 0.4 moles of a gas in a 5 liters container at 17 degrees Celsius. So it is mandatory, Martinez is telling you, it is mandatory that every time in a gas problem you have any other unit rather than Kelvin, you have to do the conversion. Okay, so this is going to be your step 0 mandatory. If the temperature is not in Kelvin, do it. Okay, convert it to Kelvin. This is going to be step 0 to convert it into kelvins. Okay, so very simple. The temperature that is 17 degrees Celsius must be turned into Kelvin. So it's going to be the Kelvin temperature is going to be your Celsius plus 273, 17 Celsius plus 273. How much is that?
209.
290 Kelvin. So the temperature for this problem must be 290 Kelvin. Now the rest of the givens are, well, a volume of 5 liters and the number of moles that is 0.4 moles. Okay? And this asking you to find the pressure. Now the isolation that I gave you from the ideal gas law to find the pressure is the following. Pressure is equal to N times the ideal constant times the temperature divided by the volume. Now, we don't have R, okay? So we need to choose it from that table. Let me bring it to you so we can choose it. Okay, according to the table that I gave you the other day, which one is better for this problem? The problem is not telling you that it needs a pressure in a specific unit, okay? But sometimes the problem tells you, okay, I want you give me the pressure in torr, for example, or in millimeters of mercury, or in atmospheres, or in pascals. So if the problem tells you, you have to do the conversion, okay? If you don't, now, if for example it's asking you millimeters of mercury, you have to use the first R that we have here, okay? Because this one is in millimeters of mercury. But if for example I tell you pascals, none of them is pascal, so you will have to do the conversion. Now, my personal choice, mine, Martinez, not yours. You have your own way. My favorite one is atmospheres because the number is a tiny number, okay? It's a tiny number, so I don't know. I think I save time by using atmospheres. So my personal choice is this one. R equals 0.0821 liters atmospheres divided by mole Kelvin. In the quiz, of course, I will tell you in what units I want my pressure, for example, and you will have to use the constant, the ideal gas constant that it corresponds. So in my case, because I prefer to use atmospheres, so I'm gonna be using this R, 0.0821 liters ATM over mole Kelvin. Once I have my data over there, I will get rid of it because I don't need it anymore. I just need to apply the formula. So very simple process, just replace by the given. So you will have the pressure is going to be equal to 0.4 moles times the R. The R I put it in two lines, okay, because my units are like in a fraction. So I write my R, my constant, like this, 0.0821 liters atmospheres up, mole, Kelvin down, and this I multiply times the temperature, which is in Kelvin, 290 Kelvin. Please use the temperature that we already converted. because if for some reason you do the conversion but you forget to use it, it's pointless, okay? So don't forget to use it. 290 Kelvin, all this divided by 5 liters of the volume in the container. So this allows me to eliminate moles with moles, kelvins with kelvins, liters with liters, and the remaining unit is going to be ATM. So how much is this?
1.90.
1.90, and the unit ATM. Okay, that's it. And in the last part, maybe I can do it. I think I can. In this last part, I have this is Graham's law. Okay, and it says that a nitrogen molecule travels at about 505 meters per second at room temperature. Find the velocity of a helium atom at the same temperature. Okay, so here I'm relating two gases. They are telling me nitrogen molecule. You have to read carefully because it's telling you a nitrogen molecule and they're asking you of a helium atom. Okay, so this is the comparison that you are actually doing. Okay, so you are comparing nitrogen molecule with helium atom, but a nitrogen molecule is not single nitrogen, it is diatomic nitrogen. So in this case, when it refers to nitrogen molecule, it refers to a diatomic molecule for nitrogen. So this is actually N2 because it is diatomic. But helium is not a diatomic gas, it's not a diatomic element. Helium is just helium. Okay? Now, I know that this nitrogen molecule travels at a speed of 505 meters per second. And I want to know the velocity of the helium atom that is at the same temperature. Just remember, helium is not diatomic. Now, according to Graham's law, what I have to do is I need to relate the two substances, okay? I put up the substance I want to know. For example, in my case, I say helium comes up and below the nitrogen, okay? Okay, now take a look. This is going to be equal to the square root of nitrogen's atomic mass divided by the square root of helium's atomic mass. Okay, for nitrogen as a diatomic molecule is going to be the square root of 2 atoms of nitrogen divided by the square root of 1 atom of helium. This is equal to the square root of 28 divided 2 times 14 grams divided by the square root of 1 times 4 grams. Okay, this is the same as the square root of 28 grams divided by the square root of 4 grams. In the end, the grams doesn't matter because you're going to erase them. You're going to cancel them. So how much is this relationship? Square root of 28 divided by the square root of 4. How much is that?
2.65.
2.65. This 2.65 means something. This tells me that helium is 2.65 times faster than nitrogen molecule. That's what it tells me. Now what I do is I'm gonna take my relationship helium over nitrogen and my answer that is the 2.65. So I say helium over nitrogen is equal to 2.65. I isolate helium and I say helium is equal to 2.65, the velocity of nitrogen, the nitrogen molecule. And this is nothing more than 2.65 than the velocity, the speed that is 505 meters over second. How much is this? How much is this?
1,328.25.
0.25. And take a look. This is it. As you can see, this is very simple, but you need to be careful with the way the problem is written. A nitrogen molecule is just a diatomic molecule, so you have to consider that the mass is gonna be twice. And some other gases have a bigger molecule, okay? Like the example I did in the video. So I recommend to watch the videos again. Well, that's it.